Alright, hi everyone, back again. So, just getting things kind of tuned up here, and got this radio sound happening now. The sound is coming out of this bunch of ferrite that's in the primary and secondary driver there. Third coil resonator up there, and running to that ferrite, counter wrapped, and then to the top load, kind of single, 1, 2, 3, 4, 5, yeah, a couple turns at the end there, acting as the top load. And right now it's deliberately just a little bit off, so you can kind of hear as I go forward and back away from it here, plays with the light, and you can hear the radio out of tune sound. So it's even more pronounced when I'm even further off of the right frequency on the push-pull driver, but right now it's sitting at about 43 kilohertz on the push-pull driver, and at times I've got oscillations around 1 or 2 megahertz on the Tesla coil. I'd say more accurately about 909 kilohertz here, and that push-pull is just reading that little noise there. It's about 40 kilohertz instead of 107. So right now I've just got the lower green trace just laying in free space here, and that's just catching oscillation off the Tesla coil there. And the push-pull driver, that's the top yellow trace. So if we turn off the Tesla, okay, so first we will, this is a problem that a lot of people have, that I've noticed, that they'll approach the top load and it'll give you what you want. Ow, damn. But with a grounded aluminum plate, just from the ground lug to this aluminum plate, adjusting the distance away, so you can see how it really picked up there. So we're just going to adjust the distance away from this with this plate. We also want the noise to die down. So we've got probably the most intensity here on the light, and just quieted down, except we're flickering in and out of the sweet spot. You can kind of hear it twitching. So after the plate adjustment, and I know the capacitance is correct on the bifilar wrap and on the grenade winding, so what I'm going to do is tweak the Tesla coil potentiometer here slightly. Yep. Too much, back down, too far, back to the middle. Great. So I'm going to tonight work on the synchronization circuitry, first building the Akula driver for the Tesla coil primary, and I do actually have a winding off of the push-pull transformer, which I've got free ends coming out to go into the full wave bridge and run higher voltage DC right into the right down the throat of the primary there. And you can see he's got a little protection light bulb indicating that the DC is charged up to deliver to the primary. And then the hex inverter chip and the Schmidt trigger, can't remember which is which there, but those will be set at that timing there that you see. Anyway, so got a few transistors that I needed and whatnot here. Start working on that. But just the tuning of having the grenade just the way I wanted, and having the capacitance just right on the output. So I've got a bunch of fixed value caps that I'm going to switch once I've decided these positions. So I'll adjust the 10 nanos. So you do get a few little higher points here and there, but yeah, you can really tell where the intensity is best. So that was adjusting the bifilar, 3 turns or 4 turns coming off of the push-pull driver, going to the series capacitor here, which is variable, and to the bifilar wrap on this half of on the core there. So we've got 14.7 nanos on that, tuned for about 52 kilohertz on the push-pull driver. I guess we're sitting at what was it? 43 kilohertz happens to just be where it happens to give the best intensity, just because of parasitic capacitance and inductance. But so yeah, we'll turn off the Tesla coil, and I wouldn't say that everything is coming out of the Tesla coil like some people say, but I'll kill the positive to the Tesla coil, and at the particular frequency and duty cycle that it's set to on the push-pull driver, this aluminum plate actually acts as the other aluminum plate. It really picks the light up when I'm just dealing with the static field a little bit better. Anyway, so yeah, you can see here only about 30 watts are being consumed with the push-pull driver on without the Tesla coil running, but having the Tesla coil on triggers some kind of a runaway thing where more current is able to flow from the mains, I guess, in this case. But with the Tesla coil on, it triggers it to really just whip right on. And this little bubble that's around the top load is really an advantage if you're tuning that as well. So it likes to have a nice wide field in this case, but sometimes like on my other Tesla coil running 1.5 volts, it likes to be really close so that it doesn't need to produce such a big field to get the result. But anyway, we're too close right now, we're stifling it. That really picked up there. But if you don't have this plate, then you can't tune it up close. You'd have to get these capacitors and everything on a longer run so that you could adjust them without affecting this field around here. But so yeah, everything is looking good here, and with that plate at the right distance, it's not so vulnerable to to having this happen, where it kills the light because you've killed the field. So at least in this example, you can really tell that the Tesla coil is doing something. I really think it's the oscillations coming off of the base resonator there, mixing with the positive of the input of this push-pull driver. The center tap is really sharing a good connection with here, so when the Tesla coil is running, that is really going to oscillate and share that here, which is, well, clear when I kill the Tesla coil, and that's what we're left with here, without turning up turning up or down any duty cycle or anything. So super dim without the Tesla coil running. Turn the Tesla coil back on, and we've got little fields around here. So once I start to get the neon lit is when the field is interrupted. So that's pretty interesting. I did have that ferrite pulled out, but when that happens, the Tesla coil does not. It's just out of range of the frequency that the push-pull's running, the wrong harmonic or whatever it is. So, and then another thing is a lot of people, I think, have the ferrite, this counterwound ferrite here, fixed in a way, but we can see here with adjusting, I've got this little reaching thing, so I don't have to get right up close to it, but we can adjust the distance to that, get a little closer. The light almost drops noticeably. Back up. So you really don't want to stifle it by having it too close. And you can hear that radio sound kick on again. Yeah, so you really just want adjustability with all of the different elements. I was thinking of even putting the primary directly around the resonator again, but I really like the Tesla resonator kind of 3-coil thing, where the primary and secondary are just closely coupled, tuned to a quarter wave, basically just by the natural windings of it, and equal weight in copper and stuff, but the real quarter wave resonant second rise would be in the resonator, acting as a series resonant circuit. And from Tesla's Colorado Springs notes, he remarks that 2-coil systems on load will cause the primary to draw more current, but with the resonator, the 3-coil system, with primary and secondary magnetically not coupled to the resonator, it does not draw more current on load. So yeah, it's not at least not going to draw more current while it's on load. It'll change the frequency that it's running at, but that can be compromised and balanced with the distance with the plate and tuning of the rest of everything. So next would be the windings off of here to run to a full wave bridge, and then get the synchronization between push-pull and the Tesla together so that they're phase locked in the frequency that I end up going with. I've been using, playing with like 11th and 13th harmonics. It's really tough to say, though. I mean, you change 10 kilohertz and you're some different harmonic of some other fundamental somewhere else. So anyway, it's just nice if you can sweep through the frequencies, through the capacitances, play with the inductance, change the distances to everything. But anyway, right now I've got it wound not the way I've used to have it in the past. This is one way that is shown, which I've tried, and that's basically what I've got here, except the outer windings are not, they're just not what other people have used. That Rustland guy, for example. I'll see if I can pull that up real quick. So as I'm scrolling through pictures here, this is what I believe Kapanadze based the winding of the output coil on. And if you look up that Tesla patent, I guess I don't have the other patent full page there, but this would be the reverse turn sort of thing, and then contacts A and B lead off to a large load of light bulbs. So yeah, there's a cancellation of magnetic field, and I don't know, everyone's probably heard Don Smith talk about you fold the wire over and you just get straight amperage. But anyway, that's what we're seeing with Tesla's old patents anyway. 336921, I believe. Or no, 336961 patent number. And describes in the patent saying adjusting the to any load, essentially, which really falls in line with Kapanadze's thing, as long as you could maintain the resonance that could power as much as the cables can handle. But anyway, that remains to be seen. But I'll find the winding that I'm using here. Oh yes, here's that original Tesla patent showing the different windings. The very first one is what you see the old Don Smith thing as, but I've personally had better luck with the second winding, where they're basically phased the same on the ends. So they're not out of phase like the top one, they're both in phase at the very ends, so you can tap the center and the two outers at the same time without canceling anything. But the third one is where Tesla showed it reversing on itself and having a center point in the output coil. But the same amount of turns is backed off, is reversed on. So with that Akula drawing here, you can see the length of the secondary on the grenade, and then the other two that go reverse direction are essentially the same inductance combined as the original winding. So on the core of this is a B&W coil, air coil there with some 14 gauge to wrap over top of it, and then reverse direction at that moret, and then back up to the same length as it would be there. So measuring the inductance of it, I do notice that it undid the inductance by about half. So that's interesting to note, that it's really playing with the inductance when you reverse the turns like that. But it's almost a perfect half of what the inductance should be if the windings were all the same direction. So right now we can I'll just turn the Tesla coil a little bit. As it warms up, the load changes the tuning. So then, if we kill the ground to the whole thing, you can see what happens. So it's kind of just getting a bit more twitchy without the ground, but it does still run with the ground on though. As definitely changes the tuning. So whatever we did here is throwing it off. Okay, so I've got the best intensity here, but I've got this weird sound. Oh yeah, we did adjust this. So we'll try to kill the sound and watch the light. There we go. So the light really kicked up when the ferrite got the right distance away from the grenade coil, and we killed the noise as well. So if you're getting like a horrible noise coming out of your transformer, then yeah, I would say the ferrite might be too close. Well, a number of things could be wrong. Even the distance from here to the top load could be wrong. Most people don't have that plate whatsoever, so you'd be trying to just jam capacitance into places. Even this plate here, might not do it now, but taking this plate away sometimes is going to dim the light. Not in this case, I don't think, but with that plate set right, it doesn't get bothered by anything else. But yeah, sometimes I go to adjust the controls and it dims the lights a little bit, so this plate here acts as though I was standing here the whole time, basically. But yeah, that's about it for now. Gonna work on that circuit tonight and have a little more adjustability, a little more precision, phase lock the Tesla coil and the push-pull driver. Talk again.